Well, students, today we will solve a problem, uh, a project involving an outlay of rupees 5 million. Project outlay is rupees 5 million, and the information given in cash flow, and this is probability. Is cash flow and probability. And cash flow for the first year is 2, 3, and 1. Point 2, 0.3, and 0.5, 2, 3, 4, 0.4, 0.3, and 0.3. 1, 2, and 4, 0.4, 0.2, and 0.4. So assuming that the cash flows are independent, so we are supposed to calculate the expected present value expected present value and deviation. And expected standard deviation. Now let us try to solve this. So let AT be the random variable denoting net cash flow in year T. net cash flow in year T. So let us try to calculate A1 T bar is equal to 0.2 into 0.2 plus 0.3 into 0.3 plus 1 into 0.5. So A1 bar is the first year cash flow. So this is the first year cash flow 2, 3 and 1, and these are the probabilities of first year given in the problem. Okay. So if you calculate this, we get 1.8. Similarly, if we calculate A2 bar is equal to 2 into 0.4 plus 3 into 0.3 plus 4 into 0.3. If we calculate, we get 2.9. Then A3 bar is equal to 1 into 0.4 plus 2 into 0.2 plus 4 into 0.4. If we calculate, we get 2.4. So to calculate the NPV, that is NPV bar is equal to 1.8, this value divided by cost of capital is 12%, that is given in the problem. So divided by 1.12 plus 2.9 divided by 1.12 raised to 2 plus 2.4 divided by 1.12 raised to 3. So this whole minus 5. So we get the NPV as rupees 0.63 million. So this is the answer. Similarly, to, So sigma 1 equal to 2 minus 1.8 raised to 2 plus 3 minus 1.8 raised to 2 plus 1 minus 1.8 raised to 3 into 0.5. So if we calculate, this will be 0.76. Plus this will be 2 minus 1.8 raised to 2 into 0.2 plus 3 minus 1.8 raised to 2 into 0.3 plus 1.1 minus 1.8 raised to 2 into 0.5. So this will be 0.76. 2 minus 2.9 raised to 2 into 0.4 plus 3 minus 2.9 raised to 2 into 0.3 plus 4 minus 2.9 raised to 2 into 0.3. So this answer of this will be 0.9. 3.4 is to 2 into 0.4 plus 2 minus 2.4 raised to 2 into 0.2 plus 0.4 minus 2.4 raised to 2 into 0.4. So this Answer 84. Standard deviation of is equal to 0.76 divided by 1.12 square plus 0.69 divided by 1.12 raised to 4 plus raised. So this will be 1.98 and the NPV is equal to 1.41 million. So let us try to understand a problem from the chapter project risk analysis. So on the board I have solved a problem uh, of project a project involving an outlay of rupees 5 million has the benefits associated with it. Like in this project there are 3 years. This project is for 3 years, and the cash flows associated with that project as I shown you earlier. So the probabilities associated with this project are also given in the problem. So now we are supposed to calculate the expected net present value and the standard deviation of the net present value, assuming that the cost of capital is 12%. So let AT be the random variable denoting net cash flow in year T. That you can see on the other part of the board that is written. So A1 bar is the first year cash flows, first year calculation uh, of the expected values. So A1 bar is equal to 2 is the cash flow into probability is 0.2 for the first year, plus 3 is the cash flow multiplied with 0.3, that is the probability of the second year, plus 1 is the cash flow of the uh, third cash flow into 0.5, that is the probability. Okay, so if you calculate this in the first year, we will get 1.8 as the cash flow. So A2 bar, if we want to calculate 2 into 0.4 plus 3 into 0.3 plus 4 into 0.3, this will give us the result 2.9. A3 bar is equal to 1 into 0.4 plus 2 into 0.2 plus 4 into 0.4. This will give us 2.4. So the expected net present value, that is NPV bar, is calculated as 1.8 divided by 1 plus 1 2, that is 12, is the cost of capital. So this totally becomes 1.12 raised to t. T is the number of year that we are calculating. So 1.12 raised to t, here t is 1 for the first year. So 1.8 divided by 1.12 raised to 1. So 2.9, that is the second year value, 2.9 divided by 1.12 raised to 2 plus 2.4 divided by 1.12 raised to 3 minus 5 is the initial investment of the project. So the total value that we get here is rupees 0.63 million. So this is the expected net present value. Now moving on to the second part, that is the standard deviation calculation. So sigma 1 raised to 2, this is the standard deviation for the first year. So calculated as 2 minus 1.8 raised to 2 into 0.2 plus 3 minus 1.8 raised to 2 into 0.3 plus 1 minus 1.8 raised to 2 into 0.5. So if we solve this, this will give us the answer as 0.76. So continuing, the standard deviation for the second year minus 2 minus 2.9 raised to 2 into 0.4 plus 3 minus 2.9 raised to 2 into 0.3 plus 4 minus 2.9 raised to 2 into 0.3. So this will give us 0.69. So standard deviation for the third year is 1 minus 2.4 raised to 2 into 0.4 plus 2 minus 2.4 raised to 2 into 0.2 plus 4 minus 2.4 raised to 2 into 0.4. So this will give us 1.84 as the answer. So if we calculate the standard deviation of the net present value, so the values we have already calculated. So according to the formula, we will just insert them. So 0.7 divided by 1.12 raised to 2, 0.69 divided by 1.12 raised to 4, 1.84 divided by 1.12 raised to 6. So this will give us 1.98. So the final standard deviation of the net present value is 1.41 million. So this is the answer for this particular problem. So these are the stages. This is how we can calculate the net present value, expected net present value, and the standard deviation of net present value.